Dr. Blaser, can you address the microbiome and asthma?
I've gotten very involved in the microbiome in general, not just in the stomach, in the colon. We and others are working on the relationship of the bacteria in the colon and asthma. And a young doctor from Denmark came to work in my lab, Dr. Jacob Stockholm. This happened after the book was published, so it's not in the book. He's part of a study in Copenhagen called the COPSAC study. They have cohorts of moms whose kids are going to have high risk of asthma, either because they have asthma or they already have a child who has asthma. So in 2010, if I remember correctly, they enrolled 750 moms of this high risk. They got samples from the moms. They got samples from the kids at 1 week, 1 month, and 1 year of life. And then they followed these kids till they were about 6. And the question was, is there anything that might predict who was going to get asthma at the age of 6? And we did a lot of work on the microbiome in their fecal specimen. And what we found, consistent with what other people found, is that the microbiome matures over time between 1 week and 1 month and 1 year. It shows a pattern of maturation. But some kids, their microbiome doesn't mature in the normal way. In the kids who didn't get microbiome maturation normally, compared to kids who did get normal maturation, the odds ratio, the chance that they were going to get asthma when they were 6 was 3 times normal. And if you divided those kids by whether their mother previously had asthma or not, if the mothers didn't have asthma, it didn't make a difference. But if the mothers did have asthma, the odds ratio was 13. We're getting in the range of smoking and lung cancer. That's how strong that is. That was published about 2 years ago in Nature Communications. We have a new paper that's in press, Science Translational Medicine. This is another very big journal about cesarean sections. It's known that kids born by C-section have a higher risk of developing asthma. So the question is why? From this study, again, with the Copenhagen study, we confirmed that kids born by C-section were more likely to develop asthma than those who didn't. And in those kids who had C-section, their microbiome on average early was abnormal compared to if they were born vaginally. But by a year, many of them had matured, their microbiome had matured normally. But if it didn't mature normally, those kids got asthma, high risk. That's going to be published within a month or two because it's been accepted already. With Dr. Mueller and with a graduate student in my lab, Tim Borbet, we've been doing a lot of mouse asthma studies. We can experimentally give a mouse asthma or allergy. And we can show that if we perturb the microbiome early in life with antibiotics, they're going to get more allergy and more asthma. And that's interesting because a paper was just published from British Columbia. They had a really good program to diminish antibiotic use across the whole province. And they show that with diminishing antibiotic use, asthma rates are going down. So it's all connected. And furthermore, I'm part of another study that's also in press. It's going to be published probably in a month or two with scientists at the Mayo Clinic. I visited there a few years ago. Mayo Clinic is located in Olmsted County, Minnesota. It's a pretty isolated place. In general, people don't come, people don't go, they stay there. So it's a very good population to study. So I suggested, why don't you look at the effects of antibiotics in early life for certain marker diseases, including asthma and food allergy and atopic dermatitis and allergic rhinitis. These diseases all go together. They enrolled 14,000 kids who were born in Olmsted County, and they were followed up to the time that they were 14. And bottom line, if they received antibiotics in the first 2 years of life, their odds ratio of getting asthma was 2. They were twice as likely. So lots of things are pointing to the importance of the early life microbiome and the importance of, if it's perturbed by antibiotics, then there's increased risk. And the relationship with moms, that's this kind of transgenerational thing, that each generation is stepping down.
Are antibiotics in food as bad as those that are prescribed?
The prescribed antibiotic is more important because it's higher dose. In mice, when we give low doses of antibiotics to mice, it perturbs the immune system, but not so much. But when we give them the same kind of doses that kids get to treat their ear infections or their throat infections, it really perturbs their immune system and puts it on a different path.